8th grade math test 6. So the first problem, we have to divide these two, and the way we divide fractions is we multiply by reciprocal. So I go ahead and flip the second number upside down, and I know negative times negative is positive, and after I do my factor trees and cross out my ones, I get 7/4. And this time you have to convert that. You divide in and out, and the remainder goes on top, divisor goes on the bottom. Number 2, when we add these two, we need the same size pieces, our common denominator. So I look at the multiples of the bottom numbers. The first time they're the same as 10, so I'm going to multiply this by 2 over 2 to get 10 on the bottom here, and 5 over 5. Any trouble with that, just count 1, 2. That's where the 2 comes from. 1, 2, 3, 4, 5. That's where the 5 comes from. So 1/5 is 2/10. 1/2 is 5/10. Add the top numbers, carry over the bottom. Make sure you can't reduce that. Factor choose, cross out your ones. This one's already done because 7's prime and doesn't go into 10. For 3, we have to give the square roots for 81. Well, 9 times 9 is 81, but negative 9 times negative 9 is also 81, so it has two answers, 9 and negative 9, or plus and minus 9. This is another way to write the same thing. So for 4, they tell us to solve this, and solving means find what x is, right? So I got to get x. Right now I know what x squared is. To get x, I take the square root of both sides. The square root of x squared is x, the square root of 576. So remember how to narrow it down? We talked about that in class, 10 times 10, 20 times 20. So once we narrow it down, we see that 24 times 24 is 576. But you know what? We learned this up here. Negative 24 times negative 4 is also positive 576. So that's why I have two answers. That's why the best answer for this was D and not C, positive 24. Now to do number 5, we have to go ahead and jump up here, and I apologize for that. The test generator does that to me sometimes randomly. I think it's to save space, or because they like to group problems together that have the same directions. But anyways, so you just got to kind of keep track which problem you're on. Number 5, square root of 64 is 8, because 8 times 8 is 64. Square root of 121 is 11. Just add those two and we're done. 6, we're going to convert, divide in and out. When you have a repeating decimal, unless they say round, you have to make sure you write it this way. Don't round it. Put the repeating bar over the 3 because that's what repeats. That's called the vinculum. Remember that in class? Vinculum. So for 7, they give us a problem, a word problem, and tell us there's a square with 159 square inches, and they want us to find the sides. Now, well, the sides are the same. So if one side's x, the other side's x too. So the way we find area of any kind of box is this times this. So x times x is x squared. So in other words, we're solving this equation. X squared equals 159, similar to what we did just a little while ago, right? So again, we narrow it down, but this time we don't have a perfect square, so we're going to round it to the nearest tenths. So we find the two perfect squares that surround it. 12 times 12 is 144. 13 times 13 is 169. This number is in between these two consecutive, that means next to, perfect squares. So the square root of 159 is really in between 12 and 13. Because that's the square root of these two perfect squares. So that means square root of 159 is 12 point something. 12 point what? So this is where we estimate, without even using a calculator, I can get close enough to get this right. I know that it's from this side over here, it's 15 away. From this side over here, it's a difference of 10. So I have to ask myself, if it's 12 point something, it's going to be 12.123 if it's closer to this side, 12.456 if it's in the middle, 12.78 or 9 if it's closer to 13. Well, it's closer to 13, but not a lot. See, 15 and 10 are pretty close. Like if this said 15 and 1 or 15 and 3, then yeah, it'd be 12.8 or 12.9 for sure. But since these are pretty close, it's got to be 12.6, maybe 12.7. And once you get in the ballpark, you're right, there's going to be one answer that works. So we wouldn't use a negative answer for this one, because even though this has two answers, positive and negative, it's a distance. So since it's a distance, we only use the principal or positive square root for this answer. For 8, we got to find the cubed root. It's like what we just did, only we're trying to figure out what do we multiply 3 times. And as you do a little guessing and checking, you see 5 times another 5 is too small. Then I go up to 10, it's too big. And I try 7, 7, 7, it's a little too small, and you'll get it within 3 or 4 tries. 8, 8, 8, I get 512. Notice that I don't put plus and minus when my exponent is odd, only when it's even. Number 9, we are given these 3 numbers, and we know that this is rational because that radicand is a perfect square. This is irrational because that radicand is not a perfect square. And this is one of those weird decimals where it never ends, but it also never repeats. So like up here, if I showed you, if it went 0.101010, if it's repeating the same thing, then that's still rational. But if it's always changing and never ending, that's like pi, that's irrational. So the answer to this question is 2 of them are irrational. For number 10, so now remember, for number 10, we have to like slide to the left. You have to go back down here, right? Now what we're going to do is we're going to simplify that first. 36 divided by 9 is 4. So now we have to review, how do I know what to call it? You guys really need to memorize this chart because you're going to see this several times on several different tests. You need to know the difference between irrational and rational numbers, and as soon as you memorize this, it'll take you 5 minutes. You will get these test questions right for the rest of the year, and until you get these memorized, you're going to keep getting them wrong for the rest of the year. I hope that's not you. So irrational, we talked about those over here, right? Radicand's not a perfect square, pi, decimals that never end and repeat. Everything else is rational. So all these numbers are rational, all these are rational, but if you want to get fancy, integers means no fractions, whole numbers means no fractions or negatives, and counting or natural numbers means don't even put 0. Sorry about that. Oh my goodness. So anyways, since our number is simplified to 4, it is a counting number. If it's counting, it has to be whole, integer, rational, and all numbers in 8th grade are real. So that's our answer for this one. Okay, moving on. So for 11, we had to simplify this number. Negative exponents are not simplified. You have to flip them, then the exponents become positive, and if they simplify, you have to actually multiply that out. So 3 times 3 times 3 is 27. There's the answer for 11. For 12, they say rewrite. We say thank you because rewrite means we don't have to finish it. We just copy the base. For multiplying powers of the same base, we add the exponents using teams like I taught you in class. And we can stop right there because they said rewrite. They didn't say simplify. So I'm done at that point. 13, they do say simplify. So for this, when I'm dividing powers of the same base, I copy the base, subtract the exponents. Remember, it goes top minus bottom. Can't go bottom minus top, even if the bottom is bigger. So I got 6 to the third. I don't have to flip it this time because I don't have a negative exponent. But I do have to multiply those numbers because it didn't say rewrite. It said simplify. For 14, we have to evaluate. The thing is, b to the 0 power is 1, right? Anything to the 0 power is 1, except for 0. You can't have 0 to the 0 power. Talked about that in class. So just cross out your 1s. So now we're just dealing with a to the negative first. Where they tell us that a is negative 3, so I put that in parentheses, and I put that to the negative first. I don't multiply these two to make it positive. That's not true. The negative exponent means, like we've been saying, is flip it. So once I flip it, now my exponent is positive, and now I deal with the negative coefficient. So I only have one of them, not 2, so it doesn't become positive. So if I only have 1, 3 on the bottom, it's still negative 3. And when it's all said and done, we learned negative goes back out to the side if you still have 1 left. For 15, we're going to simplify. So when I got power next to a power there, it's called power of power, right? We multiply. Negative 1 times 3, Mr. Dude, right, is negative 3. Flip that upside down. Now I have to go 3 times 3 times 3. I get positive 1/27, or 1 over 27. 16, they give us this big number. They tell us to write it in scientific notation. Well, decimal has to go to the right of the first number that's not 0. So I got to move it 7 times. The reason it's a positive 7 is because this is a big number as opposed to a small number. So I was showing you up here, and I crossed it out. I was showing you up here, like this is what a negative exponent would look like, right? I'd have a bunch of zeros over here. And however many times I'd move it, that would be a negative exponent. Because this is a big number, that's why it's positive exponent. For 17, I'm looking at these numbers, and the only one that's in scientific notation is a, because the decimal's in the right spot, and I have a power of 10. All of these, the decimals are in the wrong spot. For 8, I got to put this number in scientific notation, so I have to move this 2 times, so it's 10 to the negative, 10 to the positive second, because 801 is big compared to the number 1, as opposed to this one up here, which would be small, like 0.080, that'd be negative second power. But this is the problem we're doing this time. For 19, we have a number that's in scientific notation, and we're going to put it in standard or decimal notation. We got to move the decimal 3 times. We got to move it this way this time. Because positive exponents mean big numbers, something like this, a negative exponent would mean we'd move it this way to make it smaller, so that's why this is the answer this time. And for 20, if you go ahead and take that number that's in scientific notation and put it in standard notation, you see that these two are the same. Alright, 8th graders, I hope that helped you out.